All right, this class is going to be on using DSO. Oh shit, what is this? I don't know what that meant, but okay. Using DSO to diagnose sensors and actuators. It says here, what is a lab scope? It displays trace voltage over a period of time. Now remember that. Okay, they're going to ask you about that. A lab scope just shows you voltage over a period of time. Unlike a voltmeter that gives you an average voltage, a lab scope traces out the voltage. Voltage is we're gonna go over this also. Voltage is measured vertically, time is measured horizontal. You use a single channel to view a signal signature, integrity of the component. In other words, if that component glitches or drops out a signal, you can actually see it with the trace of a lab scope, which is difficult with a voltmeter. Use multiple channels to view relationships. Okay, like valve timing, mass airflow. Let me see, front and rear O2 sensors. Now, this is voltage over a period of time. Now you can see here, we have voltage come from on the vertical plane and time horizontal. But don't get this confused, especially on the test. This is voltage, right? You can see this set from 0 to 20 volts. Now, if you have a question, feel free to jump in and ask. Make this more interesting. All right, so 0 to 20 volts. Well, if I take the leads to this lab scope and put in the car battery, and say the car battery with like 12 volts, I'm going to see, what's my thing at? Hold on. Where's my, hold on, y'all. If I go to, I'm going to see 12 volts go across like that. So you're measuring across the screen as 12 volts. I'm sorry, you're reading across the screen as 12 volts. But you measured it on a vertical plane, going this way. That makes sense? So going from left to right, that red line represents, say, the battery 12 volts going across. But it went from 0 here up to 12. Is that confusing?
Nope.
No.
All right. Now my time is left to right on the horizontal plane. And usually lab scope to be 8 by 10 or 10 by 10. I think it's a 5 by 5 also. But the ones I usually see is 8 by 10 or 10 by 10. Meaning 10 gradicules going this way and 10 going across this way. So let me back up for a second. So if I got 10 going this way on the vertical plane, and my top end is 20 volts, and I have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 divisions or 10 gradicules, right? That means each division is worth how much?
2 volts.
Sorry, say it again?
2 volts.
2 volts, exactly. How many millivolts is there?
200.
Yeah, 200.
No. I had to add it in my head.
Oh, I'm sorry. 2,000.
2,000, yes. 2,000.
I'm sorry, yeah. 2,000.
2,000s.
Oh yeah, millions of thousands. Right?
Yeah, right. Millions of thousands. Exactly.
Man, I hope I don't get an F for the day on that one.
No. It's better get it wrong now because that's on the test.
You,
He
you
goes,
and I are in the same
200
club.
would be,
Greg.
that would be centivolts.
You and I are in the same club.
now, let's break it down a little further. This is one division on Graticule. I like saying divisions, right? But internally, there's 5. 1, 2, 3, 4, 5. 5 subdivisions within this one division. So each subdivision is how much you think. It's 5 of them. And this is 2,000 millivolts you just said. And it's 5 subdivisions. How much is each subdivision?
4/10 of a volt.
4/10 or 400 millivolts, right?
400 millivolts.
Greg, you got that? Because I don't see you.
He disappeared, huh?
That was
There you
good.
go.
I was trying to slide on my phone.
You understand what we just said? That would be a no, right? All right, now we're gonna go left to right. Everybody got the voltage down, right? Oh, let me ask you this on the voltage before I go to time. I'm gonna need to know this on the test also. So if I had a signal that produces a 14 volt, let me see. Should I say this? If I have a digital signal that produces 14 volts, right? Could I see that on the screen?
Yes.
Yes, you can, because it goes up to 20 volts, and 14 volts is right here. So if I had a digital signal, it would go to 14 over and down easily. Now, if I change the scale, so they said if I change the scale to 10 volts, obviously I can't do it now, but I changed the voltage scale to 10 volts and had a 14 volt signal. What would that look like if you had to take a guess?
A spike that disappears.
Yeah, the top of it disappear.
Yeah.
Exactly. It'll be off the screen. So to get it back on the screen, you have to adjust the height of it, the voltage scale of it. Everybody understand that? Guys, it's on the test. You understand that? Everybody good?
Okay. So repeat it.
If I have a 14 volt digital signal on this particular screen I'm looking at right now, it's easy to see because this screen goes up to 20 volts. But if I readjust this screen to 10 volts, now I still had that same 14 volt signal, I wouldn't see the top of it. It goes off the top of the screen.
Yeah.
Because it'd be adjusted, because my scale would be adjusted improperly.
Yeah.
Now, going left to right, it's my time. All right, my time is how much time I need to see this digital signal on the screen. Okay, now if you see here, I got 10 divisions going across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Going across the screen. Okay. Each division is worth how much? You see it says a tenth right here. So from here to here is a tenth.
10th of a second.
Tenth of a second. How many milliseconds is that? Now we do time in milliseconds. How many milliseconds is that?
100 milliseconds.
100 milliseconds, exactly. That's 100 milliseconds. So 10 going across times 100 milliseconds gives a total time of what?
1 second.
1 second, exactly. So my time from left to right is 1 second. If I have 5/10 of a second per division, my total time would be 5 seconds. the more I increase the time, the more signals I see, the more repetitive signals I will see on the screen. Okay? Because I have more time on the screen. When I reduce the time, I see less signals on the screen. If I reduce it too much, my signal is spread across the screen. So why? You couldn't recognize it.